Find f prime of x and compare the graphs is our goal for this one. So we're given that f of x equals e to the x over x to the third. So this is a quotient. So if we want to find the derivative, we're going to need to use our quotient rule. So before we start our quotient rule, let's find the derivative of our numerator and the derivative of our denominator. The derivative of e to the x is e to the x. The derivative of x to the third is 3x to the second. So let's use this to find our quotient rule. So f prime of x equals bottom times derivative of the top minus the top times the derivative of the bottom, all over, we have the bottom squared. It looks like we have some things in common here. I have an x to the second that's in common, and I have an e to the x that's in common in the numerator. So let's pull that out. Let's see if we can do some simplifying. So if I pull out x squared e to the x, in this first piece right here, I'm left with just x. So if I multiply it back through, we'll get x to the third e to the x and minus 3. X to the third squared, well, when it's a power to a power, you multiply your exponents. So that gives us x to the sixth. X to the second, x to the sixth, that can cancel, and that will leave us with 4. So simplifying one step farther, we get f prime of x equals e to the x times x minus 3 all over x to the fourth. So that's going to be our derivative based on our quotient rule to try to solve. So now it says to compare the graphs. Well, here we have our graph of f. And a little piece over here. And then here we have our graph of f prime. So if we compare our graphs, it looks like we have a minimum right here on our original graph, which is going to correspond to a 0 on our derivative. It looks like our original graph is decreasing to that minimum, so our graph is going to be below the x-axis. It looks like our original graph is increasing out of that minimum, so our graph will be above the x-axis for the derivative. On the other side, it looks like it is decreasing, so it will be below the x-axis. So we have our comparisons here. When the first derivative is negative, then the original graph is decreasing. When the derivative is positive, then the original graph is increasing. When the derivative is 0, then we have a horizontal tangent, which in this case is at a minimum. Let's look at number 10. Suppose that f of 3 equals 4, g of 3 equals 2, f prime of 3 equals negative 6, and g prime of 3 equals 5. Find, and then we have a whole collection of things to find. Find the following values. So here we go. Let's look at this. Let's look at this very critically. Here we have p of x, and notice that is adding f and g. Here we have q of x. Notice that is multiplying f and g. And then here we have r of x. Notice that is dividing f and g. So if I want p prime of 3, well, first we need to recognize that p of x is f of x plus g of x from our given information right here. So if that's the case, then we want p of 3, well, we want p prime of 3, but let's go through p of 3 first. So p of 3 is going to look like f of 3 plus g of 3. Now let's look at the derivative. P prime of 3, this is a sum. The function f and the function g are being added together. So that means we can take the derivative by taking each derivative and adding them together. So now we need to look at our given information. I am given f prime of 3 right here. So f prime of 3 is negative 6. And I'm given g prime of 3 right here. So g prime of 3 is 5. So that means that p prime of 3 is going to look like negative 6 plus 5, which will simplify to negative 1. Let's try the next one. we need q prime of 3. Let me erase some of this so that we have it a little bit more clear. So q prime of 3, q is this one right here. So that's going to be a product. So if I want q prime of 3, we're going to start with q of x. We know that that is f of x times g of x. So if I want q prime of 3, then that's going to be our product rule. Let me back it up one step so that you don't get confused. Let's look at q of 3 first. Q of 3 will look like f of 3 times g of 3. This is a product. Here's our first, which is f of 3, and g of 3 is our second. So looking at our product rule to figure out our q prime, our derivative. Our product rule says to take the first, so that'd be f of 3, times the derivative of the second, plus the second, times the derivative of the first. So if we simplify this all down, well, let's see, do we have these values so that we can substitute them in? F of 3, here it is, f of 3 equals 4. G prime of 3, right here, g prime of 3 is 5. G of 3, right here, g of 3 is 2. F prime of 3, here it is, f prime of 3 is negative 6. So simplifying down, 4 times 5 gives us 20. 2 times negative 6 is negative 12. 20 minus 12 gives us 8. Let's try the last one, r prime of 3. Well, that means that we need to start with r of x r prime of 3. Well, r of x is given to us as the quotient of f of x over g of x. So let's start with that. So that means if we want the derivative, r prime of 3, we're going to need the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So let's substitute in our values. G of 3, we're told is 2. F prime of 3, we're told is negative 6. F of 3 is 4. And G prime of 3 is 5. All over, we need G of 3, which is 2, and then squared. So if we simplify this down, it looks like we have 2 times negative 6 is negative 12, minus 4 times 5 is 20, all over 4. So simplifying a little bit more, that'll give us negative 32 over 4, which is equal to negative 8. Let's try again. This time, we don't have a whole lot of information. Instead, we are given graphs. So what we're trying to do here is look at our formulas, but we have to get our values from our graph. So let's try the first one. We're trying to find u prime of 1. Well, u of x is a product. So u of x equals f of x times g of x. So that means that our derivative, u prime of x, will be our product rule. So our product rule says the first times the derivative of the second plus the second times the derivative of the first. Now we need u prime of 1. So that means we need f of 1, g prime of 1, plus g of 1 and f prime of 1. So we're going to have to figure these out from our graph. So if we're looking at the derivatives, that's the slope, remember. And then if we're looking at the f of and g of, that's the point. So f is our red, g is our blue. So we're looking for f of 1. So we're looking for our x value when f is 1. So that looks like we're going to get 2. Now we're looking for g prime of 1. So that means we're looking for the slope of g right here. So this looks like it's down 1 over 1, down 1 over 1. So that slope looks like -1. G of 1 looks like 1. And f prime of 1, so we need our slope right here. So it looks like we have a rise of 2 and a run of 1. So a rise of 2 and a run of 1 is a slope of 2. Simplifying, 2 times -1 is -2. 2 times 1 is 2. -2 plus 2 is 0. So it looks like our u prime of 1 is going to be equal to 0. Let's try the next one. Here we need v prime of 5. Well, v of x, we're told, is f of x over g of x. So if we use our quotient rule, we get the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So we need g prime of 5, v prime of 5, excuse me. So that's going to look like g of 5 times f prime of 5 plus f of 5 times g prime of 5 all over g of 5 quantity squared. So let's see if we can find some values. G of 5, so here's 1, 2, 3, 4, 5. It looks like it's right here. So I'm going to mark that so that we have it. So g of 5 looks like 2. F prime of 5, that's right here. So we need our slope. So if we look along this line, it's a straight line, so we can find the slope at any point along that line. It looks like we have down 1 and over 3. So that would be down 1 over 3, make it a negative, so -1/3. F of 5 is right here, and that looks like 3. And then g prime of 5 is our slope for this one. And it looks like right here we have a rise of 2 and a run of 3. All over g of 5 is 2. So let's clean this up a little bit. Looks like -2/3 minus 3 times 2 is 6/3 all over 4. Yes, you could do 6 divided by 3, but if we are looking at combining our fractions, we'll have to split it back out. So if we simplify this a little bit more, -2 minus 6 is -8 over 3. This would be 4 over 1, so we can multiply by the reciprocal, which would be 1 over 4. 8 and 4 can simplify, so it looks like we're left with -2 over 3. So our value at v prime of 5 will be -2/3.